Hello again, folks. Welcome back to Incidental Information. I'm Mark, and I appreciate your clicking on the video, coming back for another, I don't know, half hour or so of audio and visual punishment. What am I doing today? Well, if you've read the description for the video, you know that we're going to be making a brooch. And as much as I'd like to be making a rotary brooch, or a tool for a rotary brooch, I don't have a rotary brooch. It's on my bucket list. Oh, thank you. The furnace went off. We have a nice wood stove, a nice fire in the wood stove today. It's February. It's cold. It's snowing. So, good day to be in the shop. So, what are we doing? We're making a brooch. And we're making the brooch for, it's going to be a conventional push type brooch. Straight through, one pass, we're done. Because it's a hex brooch. If you've seen brooches being used, typically for a keyway, they'll take multiple passes with just a few thousandths, per tooth, and maybe 20 thousandths per pass, and they'll continually pass that through the ID of a pulley or gear or whatever, and cut a keyway. When doing polygonal, pronounce it as you like, shapes, squares, hexes, what have you, where you're cutting on multiple sides of the brooch at once, it's typically a single pass brooch. So you're dimensioning largely to your finished size, and then you're just taking out corners or what have you. And then, so that's what we're doing here. It's going to be a hexagonal brooch, 1/2 inch, and I'm making it for Delrin plastic, which is not terribly hard to cut. So this tool is not going to be, hardened and ground and made out of tool steel and all of that. We're just gonna make it out of the, actually we're gonna be making it out of the same shafting that we're gonna be using for the final product. We're making plastic pulleys, sheaves, if you will. So let's see. How do we make this brooch? Well, we're starting with a 1/2 inch hole, and if I take a 1/2 inch from flat to flat hex, the outside dimensions from corner to corner are technically 577. We're actually a little bit under that because the corners have been relieved on this shafting. So the corners have been softened. So it's more like 568 or something like that. But we're going to design our brooch for, we're going to use the shaft that came with it, so whatever it is, it is. The point is, at 577, we'll be removing about 37 thousandths of material in those corners. So from the center of the flat, we're removing basically nothing, and then as the brooch moves towards the corner, it removes as much as 35 thousandths, 37 thousandths. So it's not a lot of material. If we take out, say, 5 thousandths per pass, which is reasonable for Delrin, might be a bit much for steel, might even be doable in aluminum or brass. It may be a bit much, but certainly for Delrin, we should be able to take out 5 thousandths without grabbing too much material and chipping it. And if it doesn't work, we'll go back to the drawing board. I don't want to make my brooch too long. I really wanted to use the brooch in an arbor press, and I only have a little bit of travel there. If I have to, I'll go to my drill press and use that. But even that only has 5 inches of travel. I'd like to, but if I have to go to a conventional press, hydraulic press or something, just to get my throat depth, then that's what I got to do. But we'd like to make it short. So, how do we make a brooch? Well, everybody should have their handy-dandy machinist Machinery's handbook, right? Does everybody have their handbook? Well, if you don't, get one. And while I think of it, I want to shout out to Joe Piesinski and say, thank you, Joe. This is the whole whiteboard thing here is kind of your thing. So I'm stealing a page from you. Okay, so making a brooch. Here's the thing about a brooch. If you've seen straight brooches, keyway brooches, you've noticed that the relief behind the cutting edge is very, very, very slight. And according to Machinery's handbook, it's typically 1 to 2 degrees, maybe 3 at most. And the reason for such a very slight relief is you don't want that tooth grabbing and pulling itself into the work. And that may not be too bad if you're cutting in one direction like in a keyway. But in the case of a brooch, or whether it's square or a polygonal brooch, where you want it to travel straight, you want it to maintain its axial alignment as it passes through the hole. You don't want it drifting. If you have too much relief, maybe one tooth is a little sharper than the other that day, and it's going to want to go south on you. And then the next tooth comes in, and maybe the next tooth wants to pull north. That low relief angle helps guide the cutting edge straight and keep your brooch on axis. So we're going to have a very, very low relief behind each cutting edge. And each cutting edge needs to be stepped. And then behind the cutting edge, behind that relief, that little relief behind the cutting edge, obviously there's a clearance gullet for collecting chips. So we need to do all of that. So what I'm going to do to start is I'm simply going to cut a taper. I'm just going to cut a straight, that's not a very good line, I'm just going to cut a straight taper, conical shape on my tool. And that's going to give me the initial profile for my cutting edges. Then I'm going to go back and I'm going to cut my my relief angles behind the cutting edges and turn my gullets. I'm hoping to do all of this on the lathe, which is not how it should be done, because I really want a square piece here. But so it's going to be a little bit modified from a proper tool, in that not only am I going to be expanding from the axis as I progress to larger and larger teeth, I'm really going to be expanding across the width of the tooth. In other words, starting from the center at this first tooth, I'm going to have basically no corners. I will have turned them away. As I progress backwards, that cutting edge will move farther and farther out until I am actually at the full width for the last tooth. So it's going to be a round cutting edge. And I'm hoping, and I don't see why this shouldn't be the case, that if I'm starting with a little bit of a flat here, just a little bit of a flat between these rounded cutting edges, it won't twist. So not only am I relying on the relief behind the cutting edge to maintain axial alignment for the hole, I'm relying on the little bit of flat, that starting flat, and the successive flats between the cutting edges as I progress up, to basically hold it in radial alignment so that it doesn't rotate as it's passing through. We'll see. It's a little bit of an experiment. I've never cut a brooch like this before. I've made some tooling, I guess similar to a brooch, when I first got involved with this hobby, but I'm going to be a little bit more serious about this. So join me in my experiment, would you? And we'll see how it works out. I don't see why it won't work. It's only plastic. Yeah, famous last words, right? Like the Okay. Let's get started. Exit. Stage left. And here we are at the lathe. Now, I just had a unpleasant discovery. What I thought was steel turns out to be aluminum. I didn't spec it. I didn't buy it. Okay. Full disclosure. This is part of a project that I am doing as part of my responsibilities as a mentor in mentoring a FIRST robotics team. And if you don't know what FIRST robotics is, you might want to check it out because it's really pretty cool. Bunch of kids. They have robotics activities from grade school through high school and then some. And my activities are focused on the high school kids who are building a robot to complete a task which they've only learned about 4 weeks ago, and they have 2 weeks left to complete building the robot. And it's a pretty daunting task. I mean, even for a group of adult engineers, it is not a simple undertaking. Okay, so that's what we're doing. So the kids spec this out, and I suspect that they chose aluminum, or maybe they didn't. I'll find out this afternoon. They chose aluminum to keep the weight down because the robot has to meet a certain weight limit. And this year we've got a few more motors on there, and motors are heavy. So nevertheless, it's aluminum. So can we broach Delrin with aluminum? I guess we'll find out. I don't do this ahead of time, folks, just so you know. It's not like I complete the project. I admire those guys who take the time and effort to do all that, but I don't have the time. I'm really probably just too lazy to put in the effort. So we learn together here, you and I, which is kind of cool. So we all learn together. So here we go. So it goes. Let's start by turning a 1/2 inch round on the end of this. I'm using the collet instead of a chuck. I'm using a 9/16 collet, which is really quite snug, even before it's clamped down. But it seems to work. Seems to turn pretty true. I'll zoom you in here if you like. Okay, so hopefully we're in focus now. This my eyes in this little screen probably don't work as well as the indicated 1.9 feet on the display. So we're gonna go with that. So let's turn some corners off of this for about a 1/2 inch or so. You'll notice I'm using my favorite like 50,000th radius tool here again. Works pretty good on aluminum. I got a lot of stick out here, so it's not really chattering, but I'm getting a lot of spring, so I think I might put a center in this. Let's center it. Okay. Didn't get the... There we go. This is a very sharp center that I basically use only for aluminum and brass. It's got a slightly attenuated cutting edge on it, as one might expect for brass. Where's my brush? That's not coming off. Okay. Good with that. Get my live center in here. Get some swarf off of there. And let's see how much misalignment we had earlier. Well, actually it shouldn't be, because the center should have drilled on the same center that this was cutting on before. And yes, it certainly seems that way. Except now I don't have the ringing of the chatter. Off camera, I have done a few quick calculations and determined that I have 2 3/4 inches here to play with. If I simplify that and just say 2.5 and divide that up into 1/4 inch chunks, I have enough teeth at 1/4 inch spacing to take 3.5 thousandths per tooth to go from 1/2 inch to 5/77. So I need to cut a taper on here. So that's where I'm going to start. I'm going to start by cutting my taper. And the calculator tells me that taper will be about 1 degree. So I've set my compound to roughly 1 degree. I didn't use a sine bar or anything like that. Just, it's not critical. And so we're going to do that first. All right. So, for no particular reason, I'm going to leave everything right where it is. I'm going to make my first undercut right here. I have to plunge in fairly deep to get off of this radius, so I think I'm going to regrind a tool. Okay, boys and girls. Okay, so this is the tool I've chosen. I've reground it. Nothing fancy, very classic, right out of the textbook, kind of fairly aggressive for back rake and angle and clearance and all of that on aluminum. So I'm not being inventive, and I'm going to feed this in with a compound at 7 degrees, which is my selected cutting angle. And I selected rake, and this will be the first and shallowest cut. It will stop when I see the cut reach the center. Maybe I'll go a little past that. Then I will make successively deeper passes as I go down. They should all look pretty much the same. They should follow this taper in a similar fashion. So here, the center of the flat will determine my depth, how deep I need to go. When I get to this end, the more or less the center of the radii that I've tapered on the taper here is going to determine how far I need to go. So I'll give myself a little clearance in the rake for chip clearing, and then we'll come back later, and I'm going to do a little work on the relief angle behind the cutting edge. So I'm going to leave, well, you'll see. Let's go. So I've not yet reached the center of the, so a little more. And as soon as I feel the interrupted cut stop, that's about where I should be. So I want to go just a little more than that. So if I make 10 cuts at 3.5 thousandths per cut, I've set my compound to 0. So my next cut, I will proceed to 3.5 thousandths deeper. And I'm going to come down past here so I can cut my relief angle. So I have material to cut my relief angle into behind the cutting edge. That looks good. I'm just eyeballing this. So 3.5 more this time. There we go. Next one, same deal. All right, that one went 7 thousandths, and so on. 10.5. Progressively deeper. So that one's at 14 thousandths. They do look remarkably the same. If you look at the relief, well, I guess you can't really see that from your angle. I'll move the camera later when we're all done. Okay, so that was 14. So I'm going to call that done. Now, I'm going to reset my compound to cut a 1 degree relief angle behind the cutting edge. So, this relief angle now will be in at about 1 degree. So I'm doing almost all my tool movement with the compound, which is unusual. I can't say that I do that often, if ever. got more angle on that tool than I need. It's not a problem. So, since this is what I'm considering my cutting edge now, right there, I probably want to come up to that, just about up to that. And what I'm going to do to make it a little easier to see, whoops, that was not a good crash, folks. That was a piece of instrumentation. Belongs to me, not a customer, so it really doesn't matter. Okay, let me spin this up. I want to see that bright line I will not be cutting any relief on that last piece. My compound is free to move. That should be it, in my estimation. You notice I'm starting my tool just behind the cutting edge and I'm just piercing the bluing. Okay, so now, yeah, I can feel that edge. Now we have a 1.5 degree relief, or I'm sorry, 1 degree relief behind the cutting edge, a 7 degree rake on the cutting edge, and 3.5 thousandths per tooth. So, this may end up being just a model for a steel tool, unfortunately. But we're gonna, let me show you the material we're gonna be cutting. That's the Delrin that we're gonna be cutting, and I can feel it just catches that first edge. That might be a lot of material because that's almost a circular cut. No, I can feel corners to it, but not by much. A couple of flat spots there. Well, it's not going to be cutting a piece of material this thick. It's only going to be cutting a piece of material a 1/2 inch thick. So let me turn one of those and we'll test this tool. I'm going to cut this off. Okay, there we have it. So you can see by the blue that the flat becomes progressively wider. As that flat widens, so too does the position, the radius of that cutting point is continually expanding till it meets the 577 radius of that point. Okay, Now we're going to cut off half an inch of material here, roughly. Everyone's favorite operation, parting. Gotta love plastic. Just about there. There we go. Pretty good. As somebody I know says, good enough for the girls I go out with. We get to take our new tool and see what we can destroy with it. Yeah, if this is long enough, we're gonna have to oh boy, this is not gonna be easy. I don't think I can do that in the shop here. My hydraulic press is out in the barn because everything that did not need electricity got moved out there. So I guess that's where we're going. That's where we'll be next. Got my head chopped off again here, don't I? Well, I'm not coming back over there. Welcome to the barn. There's barely room to move out here. But this is where the press is. So here goes nothing. Got my little disc. Do I have to lift my press? I might. All right, little plastic disc, punch. This should be fun. Huh. My tool for operating said press is not where it should be. No surprise there. There it is. Close the valve. Huh. There's ice on this tool. It's not cold out here. Here goes nothing. Well, I have little bits of plastic, and it feels like I still have edges, sharp edges to my aluminum brooch. So it appears that aluminum may indeed work as a brooch on plastic. Now I have to get this brooch out. I should have relieved the last of it. That would have been okay. Well, I could still do that, I imagine. Let's see. No. I gotta go find a widget. This is basically Gearhead Jr.'s shop out here. There we go. Now, let me see if the autofocus is still engaged here. Who knows? So there is a hex hole, and I still have reasonably sharp edges, it appears, on my brooch. Now there is a problem, however. Yes, I have a hex hole. What I do not have is a hex hole with clearance. So this brooch needs to be made out of a larger piece of hex and cut down. And that would require a milling machine or a team of students with time on their hands and some small files. Yeah, there's no clearance there. But it really cut fine. It really cut nice. It's a nice. I didn't lose any edges here. They're still very sharp, even for aluminum. And it didn't grumble or complain. I didn't hear any cracking or snapping of the chips. Cuts look, I don't know if you can see that. The cuts look pretty smooth. I'm rather pleased with that. So there you go. Our experiment seems to have worked. We learned something. And there you go. I'll leave it there. I'm going to go make some refinements on this whole scheme and maybe find some other material to make the next brooch out of. Because I do need clearance. It's going to be difficult to utilize these wheels without it. So, once again, hope you enjoyed that. I know I did. And thanks for watching. See you again soon.